Good morning. Today we are measuring the properties of an electrical circuit. As we go through, I would like you to complete your notes using the Cornell note format. I'll add a picture in if you need, or you can message me if you have questions. We have three main properties that we're looking at, which are summarized in this table here at the end of the presentation: current, voltage, and resistance. This table is really useful to keep track of the quantity, the symbol we use, and the unit of measurement and its symbol, okay? Although I haven't put a pencil here for you to write this down, I would recommend writing this as part of your notes, okay? So we're going to start with current again. We started looking at current last time as how many charges are passing through, or how many electrons are passing through a certain point in a circuit at any one or any amount of time. Okay, so basically we normally measure per second, and we basically measure how much charge is passing through. Because electrons are so small, if you look down at the bottom here, you can see that we actually measure charge in coulombs, which is equal to 6 times 10 to the 18 electrons. So a ton of electrons passing through every second. Current basically is the number of charges, so the number of coulombs per second. 1 amp, which is the unit we use, or 1 ampere, would basically mean that we have 6 times 10 to the 18 electrons passing through 1 point for every second. So every second there are 6 times 10 to the 18 electrons passing through. Okay, if you have 2 amps, you would multiply this by 2 to find out how many electrons are passing through. 3 amps, multiply by 3. To measure current, we use an ammeter, which is connected in series into the circuit. So it needs to be connected just like your batteries, just like your resistors, just like your light bulbs. So you need to actually connect it as part of the circuit, okay? I do have the pencil here because I would like you to summarize some of this, but I will tell you right now, the first 2 points are the most important. The third and fourth is to give you more information of how current is calculated, but I'm not actually going to ask you to calculate the current. More so, this is to just help you understand when I say the current is 1.5 amperes, that means it's 1.5 charges per second. And if you wanted to figure out the number of electrons, you could do so by multiplying this here. Okay? Pause the video whenever you need to write down your notes, or you can use the slideshow after. To measure voltage, voltage is the amount of potential energy given to each charge, okay, by the power source, which for us is usually the battery. We measure the voltage in volts, which is represented by the letter V. Potential energy is basically the stored energy that can be transferred to the electrons, okay? 1 volt is 1 joule of energy, because energy is measured in joules, per charge, per coulomb. As the energy flows through the circuit, it gets transferred to different components, like a light bulb, or a motor, or a buzzer. We use a voltmeter to measure the voltage, but we don't actually connect it in like the ammeter. What we do is we place the voltmeter on 2 different points. We touch it onto 2 different points. When we're back in class, I'll show you how to do this, or I'll show you using the simulation what it looks like, okay? The last component that we're looking at is measuring resistance. Resistance basically is how easily electrons can pass through or not. So if something has a high resistance, electrons cannot pass through very easily. Things like insulators have a very high resistance. Conductors, on the other hand, have a low resistance, meaning that the charges, the electrons and the current, can pass through really, really easily. We measure resistance in ohms using this symbol here, the omega symbol. The higher the resistance, the more energy will be transformed or changed into another form like heat, light, or sound. That is all for today.